VLPSos here. This is a video lesson for Python programming, sprite cycling. Before we take a look at this lesson code, let's take a look at what we've prepared in our file structure. We have a subfolder called sprites, which contain sprite sheets. Those are the graphic files that we import, then create a dictionary of surfaces as individual pictures that are supplied by the sprite sheet. We did that in the previous lesson on sprite sheets. We also, in preparing for this lesson where we will see a fully animated sprite, created in a separate file the dictionary of the collection of sprites that came from the sprite sheet. So here I'm showing you the separate file in which we had to make use of Pygame and OS and also create some screen settings so that we could create a screen just like we would in a regular graphic program. But in this case, the screen was prepared just to load those two images, the sprite sheets. There are 40 images, separate images of a warrior woman on each sprite sheet. One sheet is for left and one sheet is for rightward movement. So this file goes through a process, having loaded those sprite sheets, of setting up the sprite size and then going through the process of creating surfaces, filling them with clear, and then blitting the sprite sheet at particular locations in order to get a single sprite image on each of those smaller surfaces centered in the right spot. We also name them left 1 through 40 and right 1 through 40. Quite a lot of work was done. It's a process with some symmetry, so there's lots of copying and pasting to set up a dictionary like this. But after we create all the surfaces, then we create our dictionary called sprites and put those surfaces in as values with keys that are descriptive. In this case, left 1 through 40 and then right 1 through 40. The dictionary is then populated with all the sprites necessary for both left and right movement. We also put one in which is a repetition of the single sprite that was called right 1 with this new key still. So if we want to show motion to left and right, very often we need one image to be the resting image, or the default if no action is being made. We could call that a still. Once that dictionary was made, it's called sprites. It's ready to be imported by our main program. So in our main program, we did that import from warrior_sprite, that was the name of the file, the dictionary sprites. So all of our graphics now are in that dictionary. We create a class called character in order to think of the graphics as belonging to a single character. And this character we can press the left and right keys and we'll get the corresponding motion in that direction. So the character has a position on the screen. It also has an attribute called sprites, which is equal to that sprite dictionary that is sent when we create an instance of this character. And the current sprite, meaning the image that the user will see, because the user only sees one of these images at a time. Multiple images are needed in order to create the illusion of motion or animation, but the user only sees one, and we call that the attribute current sprite. And then movement could be left or right, or no movement called still. We then begin our main function, and it has a lot of familiar code that belongs to the stub. Here we create an instance of the character. There's only one in this example, and we've called the key of that character is warrior. And again, the sprites dictionary that we imported is now an attribute of that character. When a game or a program has many sprites or many characters, it's customary to have a sprite dictionary, which would be the graphics resource for that particular character, as one of its attributes. So we then create a countdown clock in our frame loop. This countdown clock, we've used the concept many times. In this case, we're calling it Sprite Cycle Counter. The Sprite Cycle Counter is an integer that is set at 2000. We have those as initialized variables here. The Sprite Cycle Counter and the Sprite Cycle Counter set with a value of 2000 to correspond to 2000 milliseconds. That's 2 seconds if it is a time measurement. And this counter is going to start at 2000 and go down to 0 and then be reset. So it's this constant 2-second timer cycle that's going on. And we're going to tie animation to that counter. So how do we do that? Well, our strategy of making animation look good to the user is, of course, to show the user only one sprite graphic at a time. And under Draw Objects, the one that we are blitting to the screen for the user to see is the current sprite, which is an attribute of our character. Whatever that value is, which will be a surface, the sprite that represents that character, the graphic of that character that the user can see, then our algorithm is all about finding the current sprite, the next one that we will see in order. So finding that current sprite out of our dictionary of 80 of them is our task. And we got to tie that to time. The algorithm in our code to do that has been mostly commented out so that we can build our understanding from basic principles first. Here's how we do that. We want to find the right sprite and assign it to be the current sprite of our character. If the motion, the movement of our character is still, then finding the right sprite is very simple. We only have one still graphic in our dictionary, and it has a key of still. So if the movement is still, then we simply assign the player's current sprite attribute the key still. And then when we're looking for that graphic, we just refer to that key to show the user. But what if the movement is right? By pressing the right arrow key, then that sets in motion the cycling of sprites to show rightward movement. Well, to begin this, we're just going to print the sprite cycle counter. That is that 2-second counter that starts at 2000 if I'm moving to the right and counts down to 0 and then is reset. We can see that the counter is being printed. We can observe that it starts at 2000 and according to real world time ticks down. Imagine that that counter is represented by a line, a bar, and we can visualize counting down, getting to 0 or below, and being reset. So we have a constant time that's ticking down, and we can literally see that here in our program. So how do we tie getting the right sprite to that time? I'm going to uncomment this where we do a simple version of what we're looking for. Let's say that we only have 2 sprites to choose from. Let's call them Sprite A and Sprite B. If there are only 2 sprites in our animation, it's going to look crude. But we can select the correct sprite out of those 2 based on our time counter. Here's how it's done. First, we need to know how many sprites we're dealing with in the full cycle of our animation. For now, it's 2. We set a variable called interval per sprite, and that's going to be equal to the sprite cycle counter set. In other words, the full amount of time for the full sequence of animation, and then divide that amount of time by the number of sprites that we have to accomplish that animation in that amount of time. Now, if there's only 2, then we could imagine dividing that time equally. If this was 2 seconds of time, then dividing it equally would mean that we would want to show 1 sprite for the first half and then the second sprite for the second half. The sprites would go A, B, and then back to A, B. And it would be kept up this regular pace according to real-world time. Well, we find which sprite we're going to use, either A or B, with this simple condition. If the sprite cycle counter, wherever we are on this cooldown, is greater than the interval per sprite. The interval per sprite is the amount of time per single sprite. This interval per sprite is going to be half if there's only 2 sprites to show in that interval. So if our sprite cycle counter is in the first half, it's going to show, or in this case, print A. And if our sprite cycle counter is not greater than half or greater than 1 interval, then we'll be in this part of the clock or cooldown and we'll print or show sprite B. We can see this regularity if we then go to the right. We can see printed out the regular A, B, 1 second for each, because there's only 2 sprites in a 2-second interval. Let's make this a little more sophisticated. What if we had 4 sprites? The number of sprites is equal to 4, which is going to then affect the math of what or how much the interval per sprite is. In other words, if we take our total amount of time and divide it by 4, then we will have 4 equal intervals, 4 partitions of this total amount of time. And what we want to do then is the math to consider 4 sprites. Let's call them A, B, C, and D. We are going to show sprite A if we are in the interval on the sprite counter that is going to be greater than 3 of these interval per sprites. Each interval is a quarter if there are 4 sprites. So if our time counter is greater than 3 of those quarters, that means that we're in the interval in which we want to show sprite A. If, after checking that, we are not in the interval above 3/4, but in this interval here that is greater than 2/4, we want to show sprite B. And as we tick down, we check one by one. Is our time counter greater than 1/4? Show sprite C. Is it neither greater than any of these quarters? We must be in the last quarter, so we show sprite D. How do we code for this? It's a simple decision tree. If the sprite cycle counter is greater than 3 times the interval sprite per minute, print A. We're going to copy this, paste it a couple of times with some elifs, change what prints to A, B, C, and D to represent our 4 sprites, and change the coefficient, the number that we're multiplying by each interval. So if we are at the beginning or the top quarter of our total time, then this condition will be true. If not, then we simply need to test the next interval down. Once we test all the ones at the top of the counter, what's left is going to be the last one at the lowest interval. When running this and pressing the key to the right to start this cycle, we should see A, B, C, D in regular succession. These letters are corresponding to the regular pattern of finding which sprite in the sequence to show the user. But 4 sprites is still very crude. Our dictionary contains 40. So I'm going to comment this out and then uncomment the very same logic and the very same math that deals with 40 sprites. We simply need to change the number of sprites to how many there are to represent rightward movement. There is a code block which looked into the sprite keys that are supplied in the dictionary. Should they change, this is programmed dynamically to count all the ones that are left and all the ones that are right, and then have a variable to be equal to the total number that are available in the dictionary. If that's the case, then the number of sprites for rightward movement is going to be equal to that variable, which I need to recopy. Right sprites. Number of sprites is equal to the number of right sprites that were found. Now this code block should look familiar if you followed the logic, except that the intervals, each interval for each sprite is 1/40th of the total amount of time. It's all there to prepare 40 sprites or to find which among 40 sprites is the next one in the sequence to assign to be the current sprite that will then be blitted for the user to see. Let's take a look. We have the still sprite, and if I press right, I get a smooth animation sequence of a warrior woman moving to the right. 40 sprites in the space of 2 seconds gives a very smooth animation. Now you've seen how to take a dictionary of sprites with keys that describe the type of motion and its position within a sequence and find which one should be shown to the user based on where you are in a time counter. Pressing the right key shows a warrior's moving right animation sequence. Make it so pressing the left arrow key shows the warrior's moving left animation. Also make the position change to correspond to the animation. Don't make it overly complicated. This has been set up for this to be achieved with a cut and paste and changing a couple of things. The dictionary already contains 40 sprites for a moving left animation. Have fun.